Hi guys, good afternoon. So in the last session, we saw IKEv version 1 site-to-site policy based between ASA and router, right? And between two ASAs was a task. So online people, did you face any problem in the task? Did you guys complete it? All right. We need to power up all the firepower devices.
So what we are doing now in organization, also we have to do them.
Exactly. Same. Let's start the UNG.
I have saved the task to the quality.
We have no. This is not the UNG you're accessing. That's a different. Yeah, that is a different. So between ASA, let's quickly complete this. Okay, I think we didn't save it or something. Says between ASA only. Okay, I think I just created, but not saved. Okay, no problem. Delete the connection. With ASA. Left to site 1. This side. Site 2.
This time is not using that VMware.
Which one?
VMware.
This is same thing, right? How do you mean VMware?
Last time actually we are using.
ESXi you're talking about.
Hmm.
No, here not ESXi. Even we can use here also. That is not an issue. If we want, we can deploy this lab also in the ESXi, but that there will be a problem because for every single lab, we need different number of devices. Okay, that's right. So that will just take up time because every time you have to deploy devices and remove devices. Okay, this is done. So here 11.1.1.1, 12.1.1.2. This is 10.2.2.2, 10.1.1.1. The kernel will be between these two ASICs. This will be 11.1 10.1.10. This will be 10.2.2.20. Okay, so who wants to do the configuration? Who wants to try? Anyone? Tell me. You can do it. Okay, so just come here. ASA.
Can we take the help from that now?
Definitely we can. But more you will type the comments, more the comments will be clear to you. Right? Okay. So
Basic configuration I have this.
start. Let's
From
see.
basic.
Yes, from basic. Just give me 1 moment. I'll wipe all the notes. Wait a minute. Now start. Online people, you guys also check if there is any mistake, then you can just point it out. Zero, right? This is the site A router. This one right here. This is like everything you cannot see there. This is just copy paste only.
Not copy paste, sir.
What difference? Try not to look at it. Site B client. Okay. Basic configuration for site A, site B done. Wait, you can. Let's give a chance to everybody.
So, VLAN configuration we can take on that. For basic configuration, I will not need the help of this month, right? But for VLAN configuration, I need.
VLAN,
For VPN,
VPN, yes.
so VPN, ISP.
These exclamation should come before ISP, otherwise it will be considered as a command.
VPN type of.
Don't help. Overall idea behind this is, if you are not doing practice at home, do it here.
And taking help is to that means this method is not that used here.
Mhm.
But the only difference if you are not this is the peer IKev1.
See, if you try to change the things, this is where you learn only.
For
Otherwise, that will just be copy paste.
all the it is the same, only that
No subnet mask. Online people, anybody wants to do the configuration? Which ASA? Config T. Check spelling. Before, after, doesn't matter. Doesn't matter. Spelling mistake. Not in Notepad. No subnet mask. No, that doesn't matter. Continue. I have missed your last 2 class due to office work. If you can share the images, I'll perform the practical. I have already shared the image link, right, with everybody. Yeah, like the EVNG images link. No. Okay, so I'll do one thing. I'll share a link today. You can download all the images. Images like these devices for installing in the EVNG. You'll find all the devices, ASA, FTD, ASA, all the devices. Yeah, definitely. How many cores you have assigned to Eve? Then definitely it will be slow. Then 4 should be good.
Using 2 routers and 91%
Mhm.
able to take access to
You have 8 GB RAM, right? Like I said, you can use virtual RAM.
that's why it's slow.
Hmm.
Yeah, the 32, 32, 35, we can.
So you can use like 25 GB you can give for RAM. Then it won't be a problem.
I think 8 GB RAM
Mhm.
right now. And what can try like 16 GB more in the remaining. So
Then
work for
yes, it will work.
16 GB.
Yes, it will become 24. But make sure it's the same frequency.
DDR4,
Hmm?
DDR4 right now.
Then same frequency, same. Is 32 GB. Is 32 GB is good for performing or all? Yes, VPN you can do it if you have if your Eve has 8 GB RAM. VPN you can easily do. Entire VPN. Almost every time we'll be using 3 devices, 4 devices, max to max 5 devices we will go. In DM VPN, we will go with routers, 6 routers. So again, 6 GB RAM on. We'll check the virtual RAM, we will check. Then it will not affect them. No, definitely not. Yeah, you can check with the processor version. It is your processor who is going to support. Okay, ready for VPN configuration? Yeah. Okay, then start. Let's see. Wait. We are saying VPN configuration, then here we use exclamation. On the site one ASA. What is the configuration you are going to do? Configuration. Idle configuration. So do it. Why this? You don't need this. Crypto. IKv1. Policy. 10. Hashing. Sure. Authentication. Pre-share. Then Diffie-Hellman group. So ASA will not support above 5. Okay. 7 is deprecated, not used. Encryption
This will not support the
above 5. That means not used. Not safe. Okay, this is done. Next is lifetime is not required. Okay. Hyphen will be there in between, not space. Tunnel group. Then 12. Here actually the name of tunnel group is there, but in place of name we have to use what? Peer IP address. So which is 12.1.1.2. Then type first. And this is LAN to LAN VPN, right? L to L. Then hit enter. Same command, but this time IPsec attributes. Well, 112 type. Type will not come. I directly IPsec attributes. Attributes. That is fine. Then IKv1 pre-shared key. No space, without space. Pre-shared key. Shared key. Hyphen. Key will be 0. You can use, you cannot use, that is totally fine. Okay, key is done. Then transform set. First command will start from crypto. Crypto. IPsec version 1. But it will be how do you create in router? Here just one keyword extra we use, that is IKv1. IKE. Transform set. Name of transform set. Then address. SHA HMAC. ESP SHA HMAC. HMAC. Mm. Then access list. Then name it tunnel, not how to name. Anything you can name. Mm. Permit. Okay. Which traffic you want to secure? Site A to site B, right? Yeah. Okay. Crypto map. Crypto map. Name of crypto map. Then no. How do you define crypto map? IKEv1. Yeah. Because see, when you're using in router, that time you have to give IPsec, ISACamp, and then after inside you will give the things. Here, directly you can set the peer. Here only set peer. Space. Now in the similar command, you will set the transform set. Okay. You did the practical, right, today? But I crypto map. IKEv1 transform set. Transform set. Then match address. Same. You will keep the same. Now what is the address spelling? Access list name. Now apply the crypto map on the outside interface. That's okay. because IKv1 is not by default enabled. Crypto spelling. Outside.
That's it for this.
Done. So how does it feel?
Hello.
Hmm? Just keep a little bit gap so that when you look at the configuration, you can easily see that, okay, which configuration where you have that. These things makes your troubleshooting part easy.
Every time we have to create this.
Where if you save your configurations, it's a benefit. Because anytime you want to perform a lab, you already have the configurations. Okay, so let's say you want to perform the lab, but you're doing without any help. Now, anywhere you're stuck, you can check where what is going on wrong and what you're missing. Okay, kind of a backup of your configuration you already have. So, site 2 policy, this will be 1111 1. This will be 1111. Here, the access list will change. Here will be 1111. Source will become destination, destination will become source. Remaining, there is no change. Now let's go and do the configuration. Right, let's see. So let's take an access. Site A, site B. ISP, ASA1, ASA2. No. Copy, paste. Site B, copy, paste. ISP, copy, paste. ASA. In ASA, after enable, keep one line gap. Why? Because it will ask for password. So host name will be this is site 1. Now what? We will first of all test the connectivity from site A to ASA. You think 10 on 10. We have the connectivity. Same way from site B to ASA, which is 10.2.2.20. This connectivity also we have. Then from ASA1 to ASA2 connectivity we will check. So from ASA1 we will ping 12.1.1.2. ASA we don't require it. In ASA, two commands are not there. One is do, another one is IP. This connectivity is a problem. No, ISP doesn't require a route. ASA don't have a route. Here route is given, on the second site route is not given. Okay. This will be 12.1.1.10. On ASA I'm giving a route. So it will be, next stop will be 12.1.1.10. Okay. Copy. Now let's check. Problem. V0 by 1 is inside interface. Okay. Copy. Okay, what about if I ping 1? Now we should have, so we have the connectivity. Now we will go and deploy the VPN. So right now, if I try to communicate that ping 10.2.2.2, so from here, I'll not be able to ping. Why? No VPN, right? And if I go here on the ASA, I'll capture the 0 by 0 interface. Now let's go and configure the VPN. Copy. So this is site A configuration done. Copy. This is site B side configuration done. Wherever transform set n is missing here. Okay. Here also transform set. Here also transform set. Copy. Meaning everything is okay. Where? Yeah, that is fine. Now it has taken already. We can check show running IKv1. No, that is different. I'm checking the running configuration. Show running. The transform set command we have to be looking. Both the sides we have to do. Now let's check again. Transform set is there. Only these two errors. 1 and 2. Where? This is IKev, right? Okay, so now let's try to pin, and we will see here whether or not do we have a negotiation. Done. Clear crypto session. Entire tunnel. Phase 1, phase 2. Now here if we see, so these 6 messages we have already seen. Okay. And first of all, any problem, any doubt in these configurations? No? Online people? Yesterday we have used this one side configuration, right? Same side configuration. You have to do it on the other side also. You just have to make sure that here, this name will be what? Your peer IP address. In place of this, if you will give something else, your tunnel will not come up. Okay. And another thing, here we have difference in what? Difference in defining the key and crypto map. That's it. And also IKev1 is not enabled, so we will enable it. These 3 things are to make sure. Okay. Now, because this is a LAN-to-LAN VPN, right? This is a format, this is a way of configuring in the ASA. In the router, we don't use this. In the router, we directly use the command crypto ISA camp, and then directly we give the key and address and then peer address. No. Site-to-site VPN is also known as LAN-to-LAN VPN because it is used for connecting one LAN network to another LAN network. No when-to-when VPN. Site-to-site VPN is a LAN-to-LAN only. Okay. All right. So, so IPsec attribute means we are defining that, okay, this is the key we will be using for IKev1. Okay, so there in one single command we define everything. Here we have to use 3 commands for defining just key only. Okay. All right. Then there we just use this crypto map, then peer, transform set, these all things we configure them below the transform set. But here in this one command we have to configure. Okay. There we go on the interface and apply it. Here we can globally decide the interface also. So this is some configurational difference between your router and ASA. Okay. Now, so far what we have seen is we have seen about these messages, and here again you can see the same things, that initiator SPI, responder SPI. So in the first message, initiator SPI will be there, responder SPI will be 0. Okay. And if we go to the security association payload, in this proposal payload, inside the proposal payload, we have transform payload. And you can see we didn't configure lifetime. It is by default taking 86,400 seconds. This is clear. Okay. Now, after this, what will happen? The second message is all about telling that, okay, this is the SA we will be using. Okay. So here also they are sharing what? Vendor ID payload. See here, this is the vendor ID payload for checking the negotiation of NAT-T, that whether they support NAT-T or not. Then message 3 and 4 are also same thing. Okay, we have here the key exchange first of all. Other than key exchange, we have nonce value, right? Nonce payload we will have. So we have key exchange, nonce payload, and then NAT-D payload for discovering the translation device. So this thing we can see here. If these assays are matching on the other side also, no translation device, not matching, translation device. If translation device, port will change to 4,500. If no translation device, port will remain on 500. This is clear? Okay. So this is message number 3 and 4, then message number 5 and 6. So in these messages, what they are sharing the identity and authentication. Okay, so these are encrypted. Why? Because the keys are already exchanged in message number 3 and 4. And here, these messages, okay, quick mode messages, they are completely encrypted right now. We are not able to see anything. So if you want to look into these messages also, okay, if you want to, not this, if you want to look here, like these are what? ESP messages. So if you want to look at these, what we can do, instead of using ESP, we can use what? AH. So AH does not provide you what? Confidentiality. That means encryption will not be there, only hashing will be there. So how we can change it? Where you are using this command, right? ESP AES. Instead of this, let me say AH. Okay. So this same command I will copy. One has ASA, then one has W794 and one has W16. But you use no, it's not based on ASA. Okay, it's not based on ASA. Okay, here in ASA we don't have AH option. Strange. So that I will show you in the router only. Okay, you can see in ASA we don't have AH option. Only again describe the differences of AH and ESP. ESP will provide you confidentiality and integrity. That means hashing algorithm you can define, encryption algorithm you can define. So all the messages right now, you can see these all messages are encrypted. If I try to look at any of these messages, I cannot see anything. But in AH, we will be able to see. Okay, because confidentiality is not there. Okay, so we have it is file save as this is IKv1 policy based site to site VPN between ASA. Okay. Now let's open the routers. And just power it off. Go with this now. This is ASN router. This is between ASA. This is with NAT. This is without NAT. See what you were saying, that in this case we were using one ASA and one router. So here the tunnel was getting established between site A and site B only. Okay. And the use of ASA was just to translation. Okay. So it's not like when you use one ASA and one router. That is not the case. Like in this case, if you see here, the tunnel establishment was between ASA and site B, right? So here the hashes will be same only. Okay. Yeah, it's not dependent on ASA. It's depending on whether is there any translation device between the tunnel. Okay. So let's go. Why this one is coming like this? Oh, this one we changed. No problem. Delete, yes. We already have the configuration, so we don't need to worry.
In interview, they are asking this configuration.
Hmm?
Configuration.
Not really configuration, but why do you use them? How do you use them? Those things they will ask.
Not asking.
You cannot predict anything, to be honest. It depends on the interviewer's mood. If the interviewer, yes. See, if you will practice right, what will you will notice that almost all the comments are same only. Very slight differences will be there. Otherwise, rest of everything will remain as it is. The concept, like everywhere we are deploying right now, as of now, whatever we have seen, everywhere we are using IP set. In the phase one, we are configuring what? Haggle and key. Then in the phase two, transform set we are configuring. Then we configure access list, crypto map, and apply it on the interface. Right? So process is the same only. It's just, how we look at it. Okay. Hmm? Can be a firewall, can be a router, depends on the interface. We have barely. I don't think anywhere anybody is using. Because right now, next generation firewalls are there. Okay. Hmm? Sorry. Anyone they can use. FTD, Palo Alto, Fortinet, Checkpoint. So force is there. Okay, anything they can use. Depends on organization to organization. Some organizations will look for cheap solution, like some will look for open source, so they might go with PFSense. So it depends organization to organization. This is site A. Mhm. Which one? Mhm. So again, the thing will depend, right? It's all about requirement. Yeah. Mostly site to site. And one of the VPN that is highly deployed is L2TP, layer 2 tunneling protocol. L2TP. I'll explain, don't worry. Coming up. ISP is up. Okay, they are all ISP is already having the configuration. To IP interface brief already has the IP addresses. Interface 80/0, no shutdown. Interface 80/1, no shutdown. One is not to do the configuration site 1 and site 2. Then site B. Copy. ISP configuration is already there. I'll perform this VPN configuration. Site B. Okay, so right now what we are doing is we are using ESP only. And let's start capturing the packets here. On the interface, gig 0/0. And whenever you're capturing packet, make sure you do not close this command prompt. If you close this command prompt, your capture will stop. Okay, you will not get any more packets here. Now, let's try to ping from here. Ping 10.2.2.2. Process 10.1.1. Okay, wrong. Interface loopback 1. This is fine. So IP interface B 11.1.1.1 and 10.1.1.1 interfaces are up. Public to public connectivity. Let's test. Here is okay. Gig 0/0. Okay, here the interface is gig 0/1 actually. That is the issue. Default interface gig 0/0. And the VPN configuration also 0/1. Now let's try. Ping 12.1.1.2. Okay. Now we should be able to capture. Ping 10.2.2.2. Source is 10.1.1.1. Okay. So phase 1, phase 2 negotiated, and we can see right now we are not able to see the messages here, like what is going on inside the packets. Okay. So what we are going to do now, we are going to go and change the transform set. That means phase 2 parameters. Okay. So I'll copy this much. Now with ESP, we were able to see AES and SHA, right? If I check here, if I use AH, with AH, I have MD5, SHA-256, 3D4, and 500. No option for encryption. Here also you can verify. Only ESP does 3 days AES. In the AH, we don't have this thing. So let's say I'll use what? SHA hatchback. Okay. And same thing I'll use AH. Okay. Now we will capture again. So I'll say First of all, let's check show crypto ISA cam. ASA. My tunnel is active. What about phase 2? Show crypto IPsec ASA. Okay. So inbound and outbound ASA is there. Let me test the communication. You see, even right now, even though I have changed my algorithms, phase 2 parameters I have changed, there is no difference. Why? No, phase 2, 1 hour. My phase 2 is still valid for 1 hour. Yes. So my phase 2 is still valid for 1 hour. The tunnel is negotiated. No difference. Now I'll say clear. Crypto. Done. Now what will happen? See, informational message was there. Let me try to ping again. This time, do you see? These are my phase 2 messages. UDP port number 500 using ISA cam. Okay, so the phase 2 information I'll not be able to see. But after that, see here, which algorithm? This time we are not using ESP. And since we are using AH, because of AH, I'm able to see that inside this, what is going on? IPv4 is there going from 10.11.1 to 10.2.2.2. And what is going on? ICMP type is what? 8, which is ping request. So this is how you can test that, okay, what is going on? What kind of traffic is going on? This way we can use AH to look into the traffic for monitoring and reporting and all. Is that clear? Because if it is ESP, we will not be able to see. Hmm? It's not like that. If I want to see, like, let's say, for example, I want to have a look that, okay, what kind of traffic is going on? So I can look at it. So it's not mandatory to have an issue only. Sometimes maybe I want to plan my network infra and security according to the traffic that is there in my network. So I want that, okay, my site 1 should have secure communication with the site 2. See, even right now, as we are able to see the traffic, right? Your ISP will not have any information here. If I say here, debug IP packet, okay. And if I try to ping, nothing on the ISP. No, it's not about AH or anything. The thing is, my traffic is passing through tunnel. Okay, so I want to have communication and I want to see that, okay, what kind of traffic is passing between the 2 tunnels or 2 sites. Hmm? Because it's not secure. Yeah, because you're able to look. ISP is not able to see. But what about somebody else is capturing it? Hmm? No, definitely. They are going through ISP only. See, this is nothing. This is not a connection. My traffic is still going through the ISP. If you look at it, my actual IP header is what? What ISP is able to see is that, okay, there is some communication happening from 11.1.1.1 to 12.1.1.2. This is only the thing my ISP is able to see. My ISP is not able to look inside. Okay. Yeah, they don't know that, okay, what kind of communication is happening. Is that clear? So this is just for monitoring and reporting purpose. Where? No, site 2. I'm monitoring on site 2. Okay. This is clear. And once you are done, then what you can do, you can go and change it back. If it has
Enterprises everywhere, ESP
ESP will be used. Yes. Everywhere ESP only will be used. Done. Now, and if you see when I change the algorithm, one more thing, when I change the algorithm, and if I say clear crypto SA, so look here, my phase 2 negotiation will happen, but my phase 1 negotiation will not happen again. You will not see the main mode 6 messages again. See, I said what? Clear crypto SA. Now look, only quick mode. Yeah, only quick mode, because my phase 1 is still active for 24 hours. I changed phase 2 parameters. I said clear crypto SA. My phase 2 tunnel went down. Then I renegotiated it with the new parameters. And now, if it is ESP, nothing is there. We will not be able to see anything.
What's the command if you want that again phase 1 will negotiate?
In that case, you will see clear crypto session. Only session, not sessions. If you will do this, now what will happen? Your phase 1 will also be negotiated again, and phase 2 will also be negotiated, because whenever there will be a phase 1 negotiation, whenever there will be a renegotiation for phase 1, so also your phase 2 will be renegotiated. Yeah, phase 1 and phase 2 both. And clear crypto SA, this will clear your phase 2 only. Okay. Now see here, if I say ping 10.2.2.2 source 10.1.1.1, now you will see all 9 messages. This is how it works. Clear? So this command will clear everything. Now you might have another question, that what if like there are multiple tunnels with multiple different sites? In that case, all the tunnels will be cleared, because with this command is going to clear everything. So here,
With 1% we can only put 1%.
See, clear crypto session. Now we have an option that, okay, here you can give ISACAM. So like ISACAM and then group, not this one. Not ISACAM, remote. Yeah, see here. You will say clear crypto session remote, and this here you will give the peer IP address. Okay, so only like right now I want to clear my negotiation with the 12.1.1.2. So this will clear with the 12.1.1.2 So you don't have to go and clear every single tunnel. Okay, and then we can go and renegotiate it. That will be renegotiated. Hmm. 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 No. There will be one tunnel created from site 1 to site 2. There will be one VPN tunnel. Doesn't matter. Doesn't matter. Now internally you can have 100 subnets. Internally you can have 100 subnets. Doesn't matter. You can pass all the 100 subnets through the same tunnel. Where? No, in capture you cannot see that information, right?
what will be the same 6 packets and
Ah.
packets will be there.
In IPsec main mode, 6 messages only. In IPsec quick mode, only 3 messages. Doesn't matter.
If they are that packet is going together.
Hmm.
So that is
So now see, all I need to do is what you're talking about is that it doesn't matter in the access list how many things you are defining. Whatever the things you will define. See, here I have said that match the access list of number 100. Now under this access list, doesn't matter how many entries you're doing. Right? Now I can define, right now I have given host. Let's say, for example, I can say it's something like, yeah, then it will become 256 subnet. Right? So, what do you mean CA? Same one only. Because this is not there according to the clients. This is there from site 1 to site 2. This is the major difference between your site to site and remote access. That site to site VPN does not require VPN tunnel setup. VPN setup on each client. Does not require a VPN setup on each client. Here, the VPN configuration will be there between the site edge devices. Okay, the edge devices will have the VPN configuration. Now, under this, doesn't matter. Let's say, for example, if I have 100 different subnets under this, 100 different subnets here. So I can just summarize them and I can put in an access list and they will connect. That is remote access. That is remote access. That concept also you can consider like, on this site itself, we have one remote access VPN configuration. So one of the client will connect remotely to this site. Now, whenever he will want to communicate through the site 2. So first of all, using remote access VPN, he will connect to the site. And from the site to site VPN will provide communication here. This is how the entire communication will be secured. Remote access. Which?
The concept of both transmission will happen, like both the transmission and
why? No, actually, again, there will be the same thing that your site 1 is going to have one public IP, right? And the client can be working from anywhere. Publicly, they will be connected because everybody is connected to the internet. So everybody will have the public to public connectivity. Now, just the VPN client we have to install there, or we have to configure the VPN in the client PC. So once the client will connect to a VPN, a tunnel will be established between client and your site. Now he's as if he's already there in the LAN network. Now what? The client can go and communicate with this entire subnet. And then after, if the client is having one IP address from this subnet in the access list, I will already have the entry. So the client can also access this site also. So there is no NATPAT concept here. Is that clear? Because whenever you're connecting with the internet, you already have a public IP. Clear? Online people? This is clear? Okay. IDP is different. That is translated IP. Port forwarding it is. One simple example I will give you. Let's say, for example, like we have configured like connected and So how we have configured here. Okay, let me just take a pen. You want to see practical implementation, right? That is what you want to see. Okay. What happened? Where? No need to make money here. We will study remote access VPN also. Now this is one subnet only.
is directly associated with that VPN.
Hmm.
When the same will be the same,
Hmm.
630.
Hmm.
There will be no other one. Just
Hmm.
only IP.
Which IP? Even again, here the IP will remain the same only,
Same.
because the entire communication will happen from site 1 to site 2 is using these two public IP addresses. So nobody will have any other IPs here. Okay.
Site B to on the for to troubleshoot from site B.
Without practice, if you will ask, then you will not understand. That is for sure.
If you have any issue from site A, then site B with the
If from any side there is an issue, the tunnel will go down. No communication. Simple. Okay. All right. I was telling you about remote access, right?
site A, you have a 50 association. Of course,
When you say 50 associate,
association is not working.
wait a
You're
minute.
not getting any connection.
Wait a minute. Wait a minute. When you say 50 associate, do you mean here I have 50 clients? Okay. So let me consider here that I have a switch here, and then here 50 clients I have. Same thing this side. No? Hmm.
All kinds of site.
Hmm. First thing, okay, first of all, you say this is what? Okay, British Telecom. Hmm. 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 Remaining are able to do. So this is not problem with the tunnel. This is problem with this particular client only. So that means this is the thing you have to test here. Here. On the site one side one. So if everybody is able to access, first of all, if it is the tunnel case, you need to check the access list.
The access will provide from site to right?
Right? Understood?
The site list.
Hmm. Three different networks. Hmm.
So we have to configure only access list, right?
Yes, only access list. With the help of access list, you are telling that, okay, which traffic will pass through the tunnel. So that is what you tell. So you can say in the same access list 100, I can say 10 network, I can say 172, and I can say 192. And now it will carry all the three traffics. Clear? Yes. So when you say you're working from home, understand this thing now. So this is your system. You are also connected to the internet. Now what? In your system, there is a VPN configuration done. When you will configure the VPN, a tunnel will be established between your system and the site. Now you are able to securely communicate with the site. That means you will get one IP address from this range. Okay. Now, whenever you want to work on the site too, so automatically when you will ping this IP address, automatically from here, see from this tunnel, your traffic will come to the site, and using site this tunnel, you will have communication here. Inside, in the remote access VPN, we don't have that concept. In the site to site, we need the static peer address. In the remote access, your destination is fixed. Source can be anything. Okay. Because source, this guy can be working from home. Maybe he's working from some cafe, railway station, airport, bus station, from anywhere he can work. Is that clear? Okay.
In my scenario, they will check both the side.
In the side to side, this will be there.
They will check both the side.
Hmm. This is clear. Now, whose address?
Client address, we work from home,
Hmm.
and we put his address and connect to the.
It doesn't matter because client, see, the client will either have a software installed, either he will have in the operating system configuration, or he will have web-based VPN. So even if he will do it, no problem, because the configuration is there on this client. No, it is not related to the IP address. Like I said, the source IP address can change, right? Every time it can change. If he's working from home, he will get a different IP. If he's working from airport, railway station, he will get a different IP. Destination is fixed. That will be in the remote access VPN. So destination is fixed, source is varied. See, one of the easiest configuration if you want to see for remote access VPN, remember, you can try what? You can try Cisco CMR. Okay, let me show you. That is one of the easiest configuration you can do for site remote access VPN. That you can understand. See, although we are going to discuss it, but since right now we are so interested, so you guys can visit this Cisco CMR. You can go for trial and demos. Depends, Meraki. I can search it. Scroll down, and here we have sign up for a free sandbox. So they will give you some VPN configurations. Okay, so let's say you log in using a Cisco account. Here. So these things will require what? A client software, basically. So what you have to do in the Microsoft Store, you will find what? Cisco AnyConnect. No, it will not reach. It will connect you to Cisco networks. And this is the AnyConnect application. It's a VPN client. Okay, so like here it is already installed, right? manage VPN settings. So all you need to do is add here and say any connect. Here connection name you can give anything. Let's say I'm going to connect to Cisco CML. So this server name or address, this is the destination address. This will be fixed, right? This will be given by Cisco. Then you will click on save. Okay, let's say for example, I'll give, I think it might be here now. See here. If I go to the VPN, this is the Cisco CML. If I go to advanced option, here this is the server name or address they have provided me. Okay, if I click on edit, this is the server name or address. Okay, so this is fixed. Now this is a URL, and with the help of DNS, this URL will be converted into an IP address. So basically, they have given me one IP address and port number 20,425. Okay, now whenever I want to connect, see right now if I show you the IP addresses on my system, so take a look here. If I say IP config, okay, so I have Bluetooth, I have wireless LAN, I have VMware, then LAN adapter local area network, LAN adapter local area network. Anywhere these, see right now you see my IP addresses. So these are all the IP addresses I have. Okay, one is 192.168.56, then 172.28.128.1, 192.168.190.1, 128.1, then 172.16.3. These are all the IP addresses. Now what I'll do is I'll go here and let me try to connect. Once I will connect to this, it will ask me about the username and password. And password, if I remember, I don't know. And you see, this is a type of SSL. Password, I don't think I remember. What was the password? Okay, right now I don't remember the password. So basically what we'll do, we will get one IP address from Cisco's network. And then after we can access the Cisco CML. Okay. So tomorrow I'll show you, I will set up again a new one that I could show tomorrow. This is clear. And right now we are not able to access here. Okay, let's go with others. Request error or cookie too large. We want to clear the cookies. Now let me try. So, transparent SNMP packet tracer. I'll use a random email from here. Now we set password. This is not it. Now we are able to access. Even VPN practice you can do here in Cisco's labs. Just go to the Cisco modeling labs and click on launch. Okay, change this to 4 hours and say launch environment. For 4 hours, you have free access. You can use a new email every day. Temporary email you can use. Labs will not be saved. Okay, so it will take like 17 to 18 minutes to come up. And you see here this quick access. So here it will give you the addresses like the server address and everything. So here you can see username is what? Developer, and password is this is 0123. Okay. This is for accessing the lab. But for that, we must be on a VPN connection. So this will take time. Okay. This is going to take time. But you will find all the details here, and then those details you can submit there and you can log in. That will be your remote access VPN only. Okay. So you can try that. I'll just send it.
4 hours per day.
Hmm?
Per day. 4 hours.
That you have to, I think 4 hours per account it is. Okay. But even if it is per account, you can use temporary emails to create different accounts. Okay. Okay. So this is clear. Now tomorrow what we'll see, we will see about route-based VPN. Okay. And before going with the route-based VPN, tomorrow you have to do a research. This is actually large. You have to research about the difference between mean mode and aggressive mode. This is what you have to check. Okay. Difference between main mode and aggressive mode. So first tomorrow we'll go with the aggressive mode. Okay. And then after we will go with the GL. That is route-based VPN. These are the upcoming topics: GRE route-based, and then we will go with IPsec over GRE. Sorry, GRE over IPsec. Okay. All right. So this is it for the day. I'll see you guys tomorrow then.